We're going to look at this first sample problem. We've got a 7 kilogram bowling ball that moves at 3.00 meters per second. The question asks, how fast must a 2.45 gram table tennis ball move in order to have the same kinetic energy as the bowling ball? And then we want to know, is that speed reasonable for an actual table tennis or ping pong ball in play? So let's kind of write down what all we know. We know that we've got a 7 kilogram bowling ball, so that's a mass of a bowling ball. I'm just going to put B for bowling. And that's 7 kilograms. We also know that it's going to have this speed, so we've got a V for speed or velocity of that bowling ball. So I'm going to put, again, VB for bowling. And that's 3 meters per second. We also know a mass for a table tennis ball. So I'm going to put an M for T for table tennis. That's 2.45 grams. And it says, how fast must that table tennis ball move? So we're going to look for VT in our question. And it says, in order to have the same kinetic energy as the bowling ball. Meaning, we need to use this information for the bowling ball to find kinetic energy and set that equal to the kinetic energy for the table tennis ball to then find its speed or the required speed for that energy. Okay, the first thing I always want to do is write out my equation. So I know that kinetic energy is equal to 1/2 mv squared. So that's half times mass and then times velocity squared. So you could even, if you wanted to, write it the v squared in parentheses, so you know the square only goes to velocity or speed. Okay. The next thing I do is I always make sure that my information that was given is in the correct SI unit. So if I'm looking at mass, it's given it to me in kilograms. I know that it has to be in kilograms, so we are good. However, if I look over here, I've got grams, and I need that in kilograms. So in order to get from grams to kilograms, we're going to divide by 1,000. So it's going to give us 0.00245 kilograms for the table tennis ball. Okay. Next phase, I'm going to change colors so it's easier to kind of keep up. So for the bowling ball, we need to find its kinetic energy. So I'm going to say KE for the bowling ball is equal to 1/2 times the mass of the bowling ball times the speed of the bowling ball squared. We can go ahead and plug in what we know. That's 1/2. The mass is 7 kilograms. Okay. And its velocity, let's move this over so you can see. The velocity is 3 meters per second, so we're going to say 3 meters per second, and I'm going to square that. There you go. All right, so now that that's squared, or we've got it written out where it's squared, again, I always, and you'll notice that I did this back in Unit 1 and 2, I always want to go ahead and distribute that so that way I don't forget to do it later. So I've got KE, bowling is 1/2 times 7 kilograms. Okay, you're going to square the 3, so that's 9. You're going to square the meters and the seconds, so you're going to get 9 meters squared per seconds squared. Okay. Now you're free to multiply it all out. So we got the kinetic energy of the bowling ball. It's going to be 1/2 times 7 times 9. And that should give us kilogram meters squared per second squared. Okay. If you notice here, I'm going to kind of take a little segue real quick. One of those meters, if you take one of those meters out, you end up getting kilogram meters per second squared, and then times meters. Okay, this is a Newton, so you got Newton times meters, otherwise known as a joule. So you know you've set everything up properly and that you did a good job distributing that square if you are able to derive the joule there. Okay, if you forget, just remember kinetic energy is always measured in joules, and just have faith in the fact that you set your problem up correctly. Okay, let's go ahead and plug and chug. So we're going to take 1/2, so that's 0.5 times 7 times 9. So it's going to give us 31.5 kilogram meters squared per second squared, which is really 31.5 joules. Okay. So we found our first part, but that's really not what the question's asking for. It says to find the speed that this table tennis ball has to go in order to have the same kinetic energy. So I'm going to take the KE for the bowling ball and set that equal to the kinetic energy for the table tennis ball. So I'm going to say KE table tennis ball is equal to 31.5 joules. Okay, well I also know that kinetic energy for the table tennis ball is going to be 1/2 the mass of that ball times its speed squared. Since both of these terms are equal to kinetic energy, I'm going to rewrite my equation, setting this 31.5 equal to that KET. So 31.5 joules is equal to 1/2 mt times Vt squared. Okay, go ahead and plug in what I know. So 31.5 joules is equal to 1/2. The mass of the table tennis ball is 0.00245 kilograms times V squared. The T again is for table tennis. Okay. All right, I can divide both sides by 1/2 and 0.00245. Okay, so that's going to give me 31.5 joules times 2, because that's what happens if you do divide by 1/2, divided by 0.00245 kilograms. And if I said multiply just a minute ago, I meant divide. I'm just getting stuff mixed up here. Okay, we still have the square here, so go ahead and write that you need the square root of that value so that you know that you're finding Vt. Okay, so 31.5 times 2 is going to be 63 joules divided by 0.00245 kilograms. So it's going to be the square root of 63 divided by 0.00245. So the square root of 25714. Okay, this is joules per kilogram. So V for the table tennis ball, it's going to be square root of that. So square root, it's about 160 meters per second. Okay, so 160 meters per second is how fast that ping pong ball really would have to go to have the same kinetic energy as this bowling ball. Okay, and 160 meters per second is an absolutely crazy speed for a tennis ball or a table tennis ball when you're playing ping pong. So this is probably not ever going to happen. So a ping pong ball probably will never have the same kinetic energy as a bowling ball moving at this speed.